Here come the drums.
Chapter 1.2, Properties of Real Numbers. What we want to do is, the set of real numbers has several subsets related in particular ways. And this whole thing with algebra, it involves operations on and relations among numbers, including real and imaginary. So what we want to do is look at the properties of real numbers and the relationships that are true for all these particular numbers. So we have to classify them. If you look over here on the left-hand side, we see that we have natural or counting numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. So what we want to do is we want to start with the basics here. We want to go, okay, those are our natural numbers. And on our natural numbers, we're going to call this, or shorthand, we can say n. And our natural numbers are just our counting numbers. These are our 1, 2, 3, 4, 5, 6, 7, and continuing. Our whole numbers, which we can label for shorthand as W, these are the same thing as the natural numbers, 1, 2, 3, but they also include the number 0. So our whole numbers are just like counting numbers except for 0. The integers, we're going to call it like the Z. Okay, integers are following the same process. We have 0, 1, 2, 3, 3, 4, 5, 6. But we now look at negatives. So we go -1, -2, and so forth down below. Okay. Rational numbers, a little bit tricky on the shorthand, but we're going to say rational, and the reason why we're not going to use R, we're going to use Q, is we also have an R here. So we're just going to separate them. These are terminating or repeating numbers or decimals. Okay, so one way of looking at it is, if we take P divided by Q fractions, okay, we can get something like 2/3, which is really 0.66666. We also have 0.25, 0.32, 56, which is really 0.833333333 repeating. Okay. Our next one, we have irrational numbers, which are non-terminating and non-repeating, and then we have real numbers, which makes up this whole set of all rational and all irrational. Okay. So for symbols, irrational, we'll just use the comforting I, and then real numbers is going to be our R. But what I like to do is draw your two lines, and then we make this little curly QR. Okay. So if we start here with N, we're going to say, okay, our counting numbers are 1, 2, 3, 4, ... Okay. When we come up to here, we have whole numbers, so W. Now these become 0, 1, 2, 3, 4, and so forth. Okay, so beginning, now we include 0. Now we get to our integers. So Z. Now we're saying we're including our negative numbers. So we start way really low, go to -2, -1, 0, 1, 2, ... If we look at this entire system, okay, these are our real numbers. These are our real numbers, and our real numbers are broken into rational numbers and irrational numbers. Okay, so rational, Q, and irrational. Rational numbers, we said, were your terminating or repeating numbers. So like your 2/3, like your -0.666 repeating. Okay, one more, 1/4. It's a pretty good one. And then we have the irrational numbers. The most famous one is pi, where non-terminating, non-repeating. We also have, if I said 3.121221222 and so forth. Or if we look at square roots, square root of 5 and square root of 2 are good examples. So let's try and put this all together and classify in many ways as possible. So the best thing I think to do is find the lowest category we can put the number in, and then everything above that should fall into place. So for instance, 56. 56 is a counting number. So the lowest, most basic we can go is to natural numbers. So we can classify it as a natural number. And then as follows, we can say natural is also a whole, which is also an integer. And if it's an integer, it is a rational number. And then all rational numbers make up the real numbers. Okay, so we have 5. Now you can also use the shortcut way. We can say that this is N, W, Z, Q, and real. Okay. So the second one, 5.6. As soon as we see a decimal, we have to at least think rational numbers. It is a stopping or a terminating, so we know it's going to be a rational number and a real. Next one, 5.6 repeating. A repeating decimal is your rational. So we know it's a Q and a real. And if we look at the last one, 5.61, 661, 6661, we have non-terminating and really non-repeating. So we know that this is your irrational, and irrational also makes up the real number system. So that's how we classify a couple different ones. How do you graph a number on the number line? So what we want to look at is, if the number is an integer, then we just determine whether it's negative or positive. If it's not an integer, then we have to determine, well, which integer is our number closest to. Okay, so if we look at number 1, negative 1, or the first one. So if we look at the first one, which is negative 1, okay, it's an integer, so we can immediately go to number negative 1 and put a dot. Okay. But when we get to the square root of 19, square roots have to do with squares, so the best thing we can do is figure out, well, what two integers am I in between if I square them? So we can start off with, well, we know 3 times 3 is 9, and then 4 times 4 is 16, and we're still below. So if I go 5 times 5 is 25, we're above. So I know if I go 4 and 4, we get 16. 5 times 5 is 25. Our number 19 is between these two, so we know it's between 4 and 5. Okay. Closest to, all we have to do is take 19 minus 16, and we get 3, or 19 minus the 25. Forget about the negative for a minute, and we get 6. So we know that the number 3 is the smallest number, so we know our number is closer to 4. Not 16, but 4. Okay, so we can go over here, we can basically put a dot a little closer there. We could even say that this is the square root of 19. 2.8. 2.8, not an integer, but we do know it's between 2 and 3, and it looks like it's closer to 3. So there's 2.8. And we have the mixed number here, so if you remember, we have negative 2.5 or negative 2.5. Okay, so we go down to the negative side, try and go right in the middle, put our dot. You have a beautiful graph. Okay. Last little part in here, if we want to compare two numbers and use inequalities. For instance, this is negative 2, that doesn't change. We know the square root of 2, well, we know 1 times 1 is 1, and then 2 times 2 is 4, so it has to be about 1 point something. So this is going to be negative 1 point something. Which one is bigger? We know that negative 1 is bigger than the negative 2. Okay? If we have 4, we'll leave 4 there. We got done with something up here just like this, where 4 times 4 is 16, 5 times 5 is 25. So we know that this is 4 point something. Okay, so 4 is less than the 4 point something, so we draw the inequality here. Okay. 5, bring it down. We know 5 times 5 is 25, so then 6 times 6 is 36, so this has to be right around 5 point something, so we know the inequality is going to go this way. And the last one, if we throw in a decimal here, 6.8, but 7 times 7 is 49. So 49 is just below this, so this is 7 point something, so we know that this is greater than. So properties. There are 5 main little properties that we look at in terms of real numbers. First two that we usually are familiar with are commutative property of addition and multiplication and associative property of addition and multiplication. So what we want to do is we want to classify and say, as we're going to look at properties to help us analyze what should we do if we were going to solve an equation when we get there. So for the first one, commutative property of addition, what we're going to do is we're going to take A, and remember A and B are just numbers. If we take A plus B, we can flip them around and say that that's the same as B plus A. So if I have 3 plus 4, which is 7, if I flip it around and go 4 plus 3, we get 7. So 7 equals 7. Multiplication, we have A times B, which should be equal, if we flip it around, B times A. So using the same numbers, we'll just go 3 times 4. Hopefully will be equal to 4 times 3. 12 is equal to 12. Associative property, think of this as grouping. Okay, what we're going to do is we're just going to assign grouping symbols and shift the symbols around and see if we can get the same thing. So we have associative property of addition. Says if we add A plus B first and then add C, that should be equal to if we added B plus C first and then added A. If we take our same numbers, we go 3, 4, 5 should be equal to 3 plus 4 plus 5. But if we add 3 and 4 first, and then hopefully we add 4 and 5 second. So 3 plus 4 is 7, plus 5 is 12, 3 plus 9 is 12. So 12 equals 12. Okay, for multiplication, using the same numbers, we're going to go 3 times 4 first, then times 5, and then we're going to go 3 times the quantity of 4 times 5. 12 times 5 is 60, and then we have 3 times 20, which is also 60. So there's commutative property of addition and multiplication and associative property of addition and multiplication. Identity. What we can do is we can ask ourselves a question. We can say, well, what should I add and multiply to the number that doesn't change my value? For instance, so if I take my number, and let's call it A, what am I going to add to A so that I don't change my A? Okay, and most of you are thinking, yes, it's 0. Okay, that's what we call, so 0 is the identity for addition. Okay, if we do the same thing here, if I take my same number A, but now I'm going to multiply, what am I going to multiply so that I still get A? And you're thinking, yes, it's 1. Okay, so 1 is the identity for multiplication. If we do inverse, now we want to think, well, how do I get the identity 0 or 1? In other words, if I start with my number, and then I add something to it, how do I get 0? And if the multiplication, as long as A is not equal to 0, or your number is not equal to 0, what do I multiply to that number to get 1? A plus what is going to give us 0? Most of you are thinking the opposite, which is negative A. Very good. Okay. Example, so I'm going to go 5 plus some number and give me 0. So the additive inverse is negative 5. Multiplication, as long as A is not equal to 0, we're going to go A times something, and we need to get 1. Okay, well, hopefully most of you are thinking, well, if I just divide by A, I get 1. So multiply by 1 over a. So if I have 5 times something equals 1, we're going to take, basically calling it the reciprocal. We're going to take the reciprocal, multiply it, and get 1. And the last one, distributive property. If a times the quantity b plus c, then we know we can distribute, or remember, multiply this, and we get a plus a times b plus a times c. Okay, if I flip the grouping symbols around, mess around a little bit and throw b out here, if I have a plus c times b, it should be equal to a times b and b times c. So what we're going to do is we're going to identify the opposite or additive inverse and the reciprocal or multiplicative inverse for each number. Okay, remember, if I want the additive inverse, what are we going to add to 7 to get 0? Oh, the answer is negative 7. Okay, multiplicative inverse, now we want to get, remember, 1. So just writing it down here, 7 times what equals 1, and that is 1/7. Additive inverse, not bad here, so negative 4.5, all we're going to do is add 4.5. Multiplicative inverse can be a little tricky. So a couple things that we can do is I can rewrite this as a fraction. So negative 4.5, which is really 4 times 2 is 8, 9. So this is negative 9 halves. Now look at this number and just flip it. Okay, and most of you will say, okay, well that's 2/9. But we have to be careful because if I multiply this times this, we're going to get negative 1. And remember that we want to get a positive 1. So we do have to keep the sign the same. So we're going to say negative 2/9. Okay, additive inverse, just negative 3/4. And what am I going to multiply? If we flip the fraction, we're going to get 4/3. Okay, additive inverse, 6/7. If I flip it, remember, keep the same sign. We're going to go negative 6/7. Name the property of real numbers illustrated by each equation. So we, based on the properties that we have, or that we just did, we're distributing. So distributive property. Over here, we are taking 16 and we're adding a negative 13. And this didn't change. We still have 16 and negative 13, but if you notice the order in which they appeared, so this is commutative property of addition. The real properties to simplify expressions. So based on simplifying, if we notice we have grouping symbols, number on the outside, what we want to do is use distributive property. So we're going to distribute the 4 to both of these. We're going to get 12a minus 4b. We're going to distribute the 2 to both of these. So we're going to go plus 2b, and then we're going to get plus 6a. Now, combine like terms, just because we want to simplify it as far as we can go. And if you notice, we have a 12a and we have a 6a, and then we have a negative 4b and a 2b. So we can combine these. 12a plus 6a gives us 18a. And then we have minus 4 plus 2, which is minus 2b. If you want to check and see how you're doing, push pause for a second, solve this, and then you can check your answer. If not, here we go. It's 6x, negative 2x, minus 14y. Hey, just remember, do your best, forget the rest. Bye for now.